Hello everyone, welcome back. In this video I am going to solve 4 bar truss element. Figure shows the 4 bar truss element. This is the first bar, this is second bar, this is third bar and this is fourth bar. If we consider this as a first node, this is second node, third node and this is fourth node. First and fourth node are fixed in all degrees of freedom. Second node is fixed in y direction only and there is a displacement along x direction as it has rollers. And if we come to the loading, a 2000 Newton load is acting in a positive x direction at node 2 and 2500 Newton of negative y direction load is acting at node 3 and all the dimensions are in meter only. So solve this in meter, or if you want to solve this using mm only, you can convert all these units into mm. Now let us learn how to solve this using Ansys. Click on this mechanical APDL icon, you will get this window opened. Select preferences, select structural, H method, click OK. Go to preprocessor, select element type, add, link 3D finite STN, click OK, close this, go to real constants, add, click OK and area 0.1 meter square, click OK. Because I am solving keeping the unit meters only, close this. Go to material properties, material model, structural, linear, elastic, isotropic, 210 exponential 9 Newton per meter square and Poisson's ratio 0.27, click OK, close this. Select modeling, create. I am creating the nodes now, create nodes. In active CS, first node should be created at origin 0 0 0, click apply. Now the second node is at 4 meter in x direction, so give second node 4 0 0, click apply, and third node is at 4 meter in x direction and 3 meter along y direction, so give 4 3 0, click apply, and the fourth node is at 3 meter along y direction, so give 0 3 0, click apply, and there is another bar that is from third node to first node. Now click OK. Sorry, we first create the nodes, click OK now and go to elements now, select auto numbered through nodes. From first node to second node, click apply. From second node to third node, click apply. From third node to first node, click apply. Here you must create this element because if you see there is a third bar from third node to first node. Again from this third node to fourth node there is another bar, so click OK now. So now we created the truss element, 4 bar truss element. There is no need to mesh this as I created the nodes and elements. We can directly apply the loads now. Go to loads, define loads, apply structural displacement, select on nodes. First and fourth node is fixed in all degrees of freedom, so click OK, select all DOF and click OK here. If you see this here, the second node is fixed in y direction. So now again displacement on node, on the second node, select the second node and click OK here. Uncheck this all DOF and along y direction it is fixed. So select UY here and click OK. See, it is fixed in y direction but it is free in the x direction. So now we must apply the loads. Go to force on nodes. On this second node, force is acting along x direction and the magnitude is 2000 Newton. So click OK here. Make sure it is Fx because the load is acting in x direction and give the load. Load is 2000 Newtons. 2000, click OK. and again there is another load along y direction, negative y direction, it is 2500 Newton at third node. So select on node, on this third node, load is acting in y direction, select Fy here, and the magnitude is minus 2500 Newton. Click OK. Now the loads are applied. Solve this. Go to solution, solve current ls, click OK. Now the solution is done. Close this. Go to general post processor, create element table. Go to element table, define table, click add, scroll this down and select by sequence number ls, give ls1 here and click OK. Close this. Go to plot result, contour plot, nodal solution, displacement vector sum, DOF solution, displacement vector sum, and click OK. So this is the deformation, 0.381 exponential minus 6 meters. This is in meters. As I solved using the dimensions, keeping the dimensions in meters, it is you must take unit in meters only. Now if you want to see the stress, go to element table, select S average, click OK. 7395.83 Newton per meter square is the stress generated, and minus 7638.89 is the stress generated again. And if you want to see reaction forces, go to list results, select reaction solution, all items, click OK. So this is the reaction force. See, at first node in x direction, this is the magnitude of force, and in y direction this is the magnitude, and at second node in y direction this is the magnitude, and in fourth node this is the magnitude. Now if you want to see this in 3D view, go to plot control, select style, size and shape, display of element on, click OK, and keep this in isometric view now. Now go to plot control, animate, deformed shape, deformed plus undeformed. Give the time delay 1 second because it will slow down. That means every deformation step will be showed per second in 10 frames. Now select, click OK. See, the load is acting 2000 Newton in x direction here, and in negative y direction 2500 Newton is acting. So this is the deformation. If you want to see this deformation in forward only, select forward only. You can see the deformation in forward direction. Okay, thank you for watching video. If you like this video, please subscribe, like and share. Thank you.